Right now, as you're watching this video, there could be infinite versions of you making completely different choices in infinite parallel universes. One version just quit their job. Another just became a billionaire. Another never clicked on this video. This isn't science fiction anymore. In 2026, the multiverse is a serious scientific hypothesis supported by some of our most successful physics theories. And there are actually 5 different types that physicists consider legitimate possibilities. By the end of this video, you'll understand each type, how they're different from each other, and which ones have the strongest evidence. Trust me, this will completely change how you think about reality. But before we dive in, we need to get something straight. The multiverse isn't one single idea. It's actually 5 completely different concepts that come from 5 different areas of physics. Some of these multiverses could coexist. Others contradict each other. And understanding the difference is crucial to separating real science from Hollywood fantasy. Let's break them down one by one. Type 1, the quantum multiverse. This is the most famous one, and it comes straight from quantum mechanics. Every time a quantum measurement happens, the universe splits into multiple versions. Here's the wild part. According to the many worlds interpretation, this happens constantly. Every quantum interaction, billions of times per second, creates new parallel universes branching off from ours. In one universe, that radioactive atom decayed. In another, it didn't. In one universe, you turned left. In another, you turned right. Every possibility that quantum mechanics allows actually happens in some universe. Now, critics say this violates Occam's razor. Why multiply universes infinitely just to explain quantum behavior? But supporters argue it's actually the simplest interpretation of quantum mechanics. You don't need to add wave function collapse. You just take the math literally. The equation already describes branching realities. We're just accepting what it tells us. The problem? These parallel universes are fundamentally unobservable. Once a split happens, those branches can never interact again. Which brings us to a crucial question. If we can't observe it, is it science? For now, let's move on. Type 2, the infinite space multiverse. This one is actually the most straightforward and might surprise you with how simple it is. If space is truly infinite, which many cosmologists believed in 2026, then every possible arrangement of matter must repeat somewhere. Not just similar arrangements. Exact duplicates. There are only so many ways to arrange particles in any given volume of space. The number is huge, but it's finite. If space is infinite, those patterns must repeat. That means somewhere out there, beyond our observable universe, there's another you, reading this exact script, in an identical room, making identical choices. In fact, there are infinite copies. The nearest identical copy of you would be approximately 10 to the power of 10 to the power of 29 meters away. That a 1 followed by 10 billion billion zeros. Of course, we can never reach them. They're beyond our cosmic horizon. Light from there will never reach us, because space between us is expanding faster than light can travel. But here's what makes this multiverse different from the quantum one. These parallel universes exist in the same space and time as us. They're just really, really far away. Type 3, the eternal inflation multiverse. This one comes from our best theory of the early universe, and it's gained serious traction among cosmologists by 2026. Inflation theory says the universe underwent exponential expansion in its first fraction of a second. But here's the twist. Inflation might never completely stop everywhere at once. While inflation ended in our region, creating our Big Bang, it continues in other regions. Those regions eventually stop inflating too, creating their own Big Bangs and their own universes. These bubble universes are fundamentally separate from ours. They have their own space and time. They're not just far away, they're completely disconnected from our space-time altogether. And because inflation is random and quantum mechanical, each bubble universe could have different physical constants, different strengths of gravity, different masses for particles, different laws of physics. Most of these universes would be dead, hostile to life. But in an infinite multiverse, some rare bubbles like ours would have conditions just right. This is called the anthropic principle. We observe our universe to be fine-tuned for life, not because it was designed, but because we can only exist in a universe capable of producing observers. It's selection bias on a cosmic scale. Type 4, the string theory landscape. This multiverse emerges from string theory, and by 2026, it remains one of the most mathematically sophisticated possibilities. String theory requires extra dimensions beyond our familiar three of space and one of time. How these extra dimensions curl up determines the physics we observe. And here's the kicker. Calculations suggest there are roughly 10 to the power of 500 different ways these dimensions could configure themselves. Each configuration is a different possible universe. This is called the string landscape. Each valley in this landscape represents a stable configuration with its own laws of physics, and they could all exist simultaneously in different regions of the multiverse. Critics call this a disaster. String theory was supposed to predict our unique set of physical laws. Instead, it predicts 10 to the 500 possibilities with no way to determine which one we should inhabit. Supporters argue this is exactly what we should expect. Combined with eternal inflation, different bubble universes could realize different points in the string landscape. The multiverse becomes inevitable, but we still have no experimental evidence for string theory itself. And without that foundation, this entire multiverse remains purely speculative, no matter how elegant the mathematics. Which brings us to the most radical possibility, one that makes all the others look tame by comparison. Type 5, the mathematical multiverse. This is cosmologist Max Tegmark's hypothesis, and it's philosophically profound. He argues that every mathematically consistent structure exists as a physical reality. Our universe is described by mathematics. But why should our particular mathematical structure be special? If mathematics is real and fundamental, then all mathematical structures should be equally real. That means universes with different dimensions, different symmetries, even different logical structures. Universes where time has multiple dimensions. Universes with physics we can't even imagine. The mathematical multiverse contains all other multiverses. The quantum multiverse, the string landscape, all of it. Everything that can be described mathematically exists. Most physicists in 2026 consider this too extreme, too untestable, too philosophical. But Tegmark argues it's the logical conclusion of taking mathematics seriously as the language of reality. So which multiverse is real? Here's the honest answer. We don't know. We might never know. These ideas push against the very limits of what science can tell us about reality. But that doesn't make them worthless. These concepts come from our most successful theories. Quantum mechanics works. Inflation explains our observations. String theory is mathematically consistent. The multiverse isn't something physicists wanted. It's something they found when they followed the math where it led. Whether that math describes reality or just our models of reality remains the ultimate question. If you found this mind-blowing, smash that like button and subscribe. Seriously, it helps us keep making videos that make the universe accessible and awesome. The multiverse changes everything about how we think about our place in existence. Whether one universe or infinite, whether alone or endlessly copied, we're still here, conscious, and able to ask these questions. And that might be the most remarkable thing of all.